C, senorita, or usted, senorita. I don't know. All right. Senora, there you go. All right, so let's quickly review pieces of this, because today we are going to do most of nomenclature. It doesn't take much time once you get the hang of it, but you want some practice time with me, so my goal is for us to get to the practice towards the end. We will do our close reading shared after I get the attention I need from you first, okay? So I think you should be very confident on a lot of vocabulary, and I'm going to be using that vocabulary and I expect that you use the same respect to me, not saying that thing with a positive charge, you should be saying what? Cation. If I said something with a negative charge, you should be using anion. Yeah. Just hold on. You had plenty of time to do that. If you're mentioning something with an ion charge, you're basically referencing the electrons, the valence electrons, and when you're referencing the valence electrons, you should say something like, oh, this has 2 valence electrons. That's going to then, what as it forms an ion?
It's going to
lose 2 to make a what charge? The cation has a what charge? Positive 2 charge. Yeah. So try to incorporate your vocabulary as we go. What kind of compounds, or what kind of atoms come together to form ionic compounds? Metals and nonmetals. So this is some background information that should be very accessible, and we're going to keep using that and referencing that throughout today. Other than that, you could also have a metal and a polyatomic ion. That's going to be where it's not just a nonmetal in general, but it's an ion, right? And ions form ionic bonds. Covalent compounds, what are they made of?
2 nonmetals.
2 nonmetals in general? Not really, there's no other exceptions to that. That is it. What kind of suffixes are we finding in ionic most of the time? Ide. And that's the binary ones. Yesterday, did we get to the types that deal with polyatomics?
No. I don't.
Okay, well, look at your polyatomic ion list and tell me what the endings are. 8 and 8. Okay. Yes, there are 2 ides. So I said typical because generally, most of the time when we end in ide, it's a binary compound. But there are 2 exceptions in the polyatomic ion list. We'll get there shortly. But most of the time, the endings of the polyatomic ions are 8s and 8s. Okay, so a couple of you guys were already naming these for me. Appreciate it. Emma, what's the name of the first one? Thank you, Emma. Your voice got really deep there. All right. Emma said sodium chloride. Cole, name the second one. Lithium oxide. So sodium chloride. Cole said lithium oxide. Savannah, next one. Carbon, and you guys have all seen this before, photosynthesis, right? Cellular respiration. We know that carbon dioxide is CO2. Everybody probably knows this one too? Carbon monoxide. Monoxide. Okay, so, one second. 2 very distinct ways we name things are how we name ionics versus how we name covalents, and that's what we're going to really dive into today. Ionics take the longer time to learn, so I'm going to spend most of my time here. I'll spend about 5 minutes here, and you'll have this as a piece of cake. What's the main difference you're seeing between these types of namings? The what? The prefixes, right? I didn't say mono or di up here. There's no need to, because these are ions, and the ions come together, and those ions have charges, and if we can all look at the periodic table and find the charges, we don't need any any prefixes. But are these ions inside of here? What kind of compound is this going to be, ionic or covalent? Covalent, because it's what? 2 nonmetals. Nonmetals are not going to come together in an ionic way, or sharing, or they're going to share electrons. They're not going to donate electrons. Same story, nonmetal, we're coming together covalently, so we have to express the name in a slightly different way. And we actually name that with a prefix, di and mono, to indicate the number of atoms present. But we never, ever, ever, ever do that in ionic. So we're going to have this divide in our thought process today as we go. Okay, so I'm going to blend them together. So you have to rationalize your first thought is it ionic or covalent? And then we'll have to go from there on how to name them. Questions here? Yes. Okay, so I'm going to give you a lot of information today. You guys have your notes that you picked up from Kelsey, right? Yes. The one we're predominantly working with today is going to be this one. Slackers didn't pick them up. Anybody else need one? Pass this back around. I have a slide, 2 whole stacks left.
Just waiting.
I'm just pouring all of you. Can you grab your own?
Wait.
Okay. Yes, you need one of each. Please don't take more because my fourth period needs it. My fourth period needs it. All right, guys, back to me. So we will be working from that shortly, but I'm gonna go through some notes first that give you the background. So the less time we have in class, the more you have to do at home, right? So I would like to try to start pumps at 9 at the end of class with you. All right, so these two laws we have mentioned before back in Unit 1, and they specifically support our thoughts on how do we name compounds and write their formulas. Let's summarize the first law. Go for it, Grant. First law. Summarize it. I'll read it straight off the board, though. That would be law of constant matter. Grant, summarize the first law.
Atoms equate to the ratio of masses.
Okay, so the number of atoms equates to the ratio of masses. That's what one person, Democritus or Aristotle, they kind of initially said, hey, this atom can come together with this atom in one ratio, and that's it. So they said one ratio exists, meaning they were always in the same proportion. But is that true to this day? Yay or nay, people?
Nay.
Nay. There's another law right underneath it. It's sequentially kind of pulling together. We went from definite proportions or defined proportions, where you had one set ratio, to another idea. Evan, to summarize that one for me.
Same two elements can have a different value.
Different ratio, right? So you can combine them in multiple ratios, aka multiple proportions. So as we learned more about how atoms came together, we were then able to understand that there wasn't a set way they had to come together, but sometimes we had the ability to form different proportions. For example, water. You'll see I have water 2-to-1 ratio. Do you know what I'm talking about there as a 2-to-1 ratio?
Yeah. 2 H's, 1 O.
2 H's and 1 O, and then same thing over here, 2 H's and 1 O, or 2 O's. So what's the formula for water?
H2O.
H2O, and what's the formula for hydrogen peroxide?
H2O2.
H2O2. So as we came to understand there were multiple ways to put things together, we had to come up with a system on how to name those atoms, or name those molecules, or name those formula units, as we call them. So the whole idea of nomenclature and naming things in a systematic way made sure that everybody was on the same page when we started to name things. So if I said, give me some baking soda or sodium bicarbonate, everyone knows what we're talking about, so that we can kind of use the same recipes and we can use the same chemical reactions to make some sort of product in a consistent manner. So this is just the background to give us the idea that that's where we're going towards. You guys can look up those definitions. It was on one of your reading guides. Okay, so we're going to start to talk about symbols say what. So we want to know what the symbols are talking about. We want to know what the numbers are talking about. And we want to be able to classify from there to do a reaction. So this is basically the way we will talk in chemistry and chemistry language, which eventually will become the language we all speak. We will. So we're going to talk about naming compounds and writing formulas today. But in order to do that, you should understand what a symbol is, which who feels good about what symbols are? It's the periodic table, right? We're looking at the symbols from the periodic table themselves. As long as you have your periodic table out, which you always should, then you'll be very comfortable with that. So as we look at the periodic table of elements, we pull their symbols, and as we combine them to make compounds, we're saying atoms are combining. Atoms of sodium and chlorine combine to make a formula, or to make a compound. So we're taking the atoms and we're combining them to make compounds now. But that's old news. We knew that could happen anyway. So the first compound I've made, you guys can name it for me. What's the name of this again?
Sodium chloride.
Sodium chloride. So that particular compound is like an umbrella term for literally everything with multiple atoms connected in them. So compound's not really informative. It's just like, hey, something's bonded together. Guess how it's combined? So instead, I'm actually going to use the word formula unit. And that's because the word formula unit is a specific term for anything that's an ionic compound. So I have, and it sounds kind of funny, but I have a formula unit of sodium chloride here. But in the case of covalent, we don't use the word or the terminology formula unit, we use the terminology molecule. So name this one for me.
Carbon dioxide.
Carbon dioxide, that we would call that a molecule of carbon dioxide. And so those are how I usually abbreviate them. But just we want to make sure we're using the right terminology as we go along. And that terminology gives me some inherent information about those compounds. So if I say formula unit, what kind of compound is it? And if I say molecule, what kind of compound is it? Covalent. And that just gives us some more information. Now, probably maybe a week and a half from now, we'll actually start to react these together. We'll react some things to make new compounds. But that's like, not us just yet. We'll get there. Alright, give me a thumbs up and I can move on. Okay. I'm videoing. These notes are on my website. You just can print them off beforehand if you wish. But this is all background right now. Okay. Alright, so when you look at this compound formula, first of all, is it a molecule or a formula unit? SO3. Say it something.
Molecule.
Molecule. Right? Why?
Because it's two non.
Okay. So you can look at a compound now and you can tell me a whole lot about it. So we know it's what? It's a molecule. And that when you say the word molecule, you're basically telling me what kind of compound or what kind of bond is in it. Covalent. Yes. So they said it was. You guys ever look at your? Does everyone have a periodic table?
Yes, ma'am.
Point to sulfur and point to oxygen on your periodic table. You definitely need to like put that. Two, and so what do you say?
Two nonmetals.
Two nonmetals. So if you have two nonmetals combined together, it is covalent. So thank you for calling me out on not making sure that was clear. Okay. So we know that this is covalent because it's two nonmetals together. Since it's covalent, we're calling it a molecule. In this covalent compound, how many sulfur atoms are in it?
One.
How do you know that?
Because it doesn't have a substance.
So that subscript that's there but it's not there is actually what?
One.
There's a 1 right there. And we don't always write the 1 because if it's blank, we just assume that there's one of that particular atom. But there's definitely what for oxygen? 3 atoms, right? So the subscripts, which are the lower numbers, which are kind of right beneath the 2 letter symbols there, that means we have 1 atom of sulfur and 3 atoms of oxygen in sulfur trioxide, which is what that name is. Sulfur trioxide. That's one we'll learn about in a little bit. So knowing the compound type, knowing how many of each I have, but knowing the compound type being covalent means you can tell me a lot about this. To the person next to you, name off some properties of a covalent compound. Name them off to the person next to you.
That's not right though. Yeah. It's also like, is it a good conductor or bad conductor? That's what I'm I know, right?
All right, 3, 2, 1. Cam's group. Tell me a property of a covalent compound. Okay, someone say poor conductors. Jasmine's group. Low melting point. Annabelle? I don't know if you just had their hand up. Y'all's group. Liquid or gas or room temperature. Good. So all the stuff we learned about last unit, right, is coming back because I could potentially say, okay, look at these compounds, decide if they're ionic or covalent, give me some properties about it, or vice versa. So that's kind of where that next, I have an arrow, I'm going to go to the next slide to show you guys that. So, with the person next to you, look at these compounds. I'll number them 1, 2, 3, 4, 5, and 6. I want you guys to write those numbers here, here, and here to state the properties that those compounds correlate with. Okay, so just make a list on your paper. Electrolytic, volatile, and probably soluble. Like probably water soluble. There's some rules beneath the rules I've told you. Make a list of person next to
Gaseous. And then gaseous. Alright, so for an
So how would you
Alright, come back to me. 3, 2, 1. Usually, I make this a quiz on the first day, like, of this unit. Because what you should be able to easily find out is, across the board from 1 to 6, you should be able to tell me quickly if it's ionic or covalent. Okay, go. Ionic.
That's really fast.
Okay, you should be able to do that, because you should know if it's, how do you know this is ionic? Metal, non-metal. Non-non. Metal, non-metal. Metal, non-metal. 2 non-metals. 2 non-metals. So you should know, this is the very first part of nomenclature. Can I identify if something's ionic or covalent? Check. Do I know a little something about that? Check. Okay, so which ones, 1 through 6, should be electrolytic? 1,
3, 4.
4. Is that it? Yeah, so which ones did you guys identify? Only the ionic ones. The covalent ones will not dissolve in solution to make electrolytes, meaning ions, which will not allow any conductivity to flow through solution. Volatile vaporizes easily. What did I say that meant, Anthony? Technically? Vaporizes easily kind of refers back to its... Right, so these have low boiling points because they're vaporizing easily, so that they're vaporizing at room temperature specifically here. And which ones would those be, guys? Those be, guys? All the what? So 2, 5, and 6. Okay, likely soluble would be what kind of things, Zane? Likely soluble in water would be what kind of things?
If they have hydrogen or oxygen.
That's going to be, you're thinking about hydrogen bonding with water, I think. Just generally soluble, like will dissolve in water. That's what I'm looking for. All right, I'll come back to you. Yeah, Emily. Yeah, all the ionic ones should generally be soluble in water. So 1, 3, and 4. Yes.
Why is that? Is the ionic bond covalent?
because generally water can pull ions apart, actually not pretty easily. A lot of times our covalent ones could be non-polar. Non-polar things don't dissolve in polar water. So that's back to like the water and oil don't dissolve kind of idea. But I said generally because, I mean, we'd have to draw these low dot structures to figure out if they're polar or non-polar, and we don't got time for that right
So
now.
technically, some of those could.
Potentially. That's why I said possibly dissolve in water. Okay. All right. So now we're going to talk about the nomenclature side of things. Okay. So that's the background. Can you identify ionic and covalent? You feel good about that now? Smile, heads in here, thumbs up, something. Give me like a. Okay. You should be able to look at metals and non-metals quickly. I want to. I think this is important. Make a list. Ionic, covalent. Let's make a chart of what would be found in a compound formula. This is like the foundation. If you get the foundation, you should be sitting pretty. So key differences in ionic and covalent compound names or formulas are as follows. Ions are in which type? Ionic, right? That makes sense because it's ion. Okay, so it's a bond between two ions, right? Covalent, no ions. Don't even consider putting charges on these. Okay, so these will have charges. These will have no charges. Next, well, I think we got that now. But if there's a metal present, probably it's going to be ionic. If there are no metals present, it's going to be covalent. So the metal could either be bonded to a nonmetal or the metal could be bonded to a polyatomic ion, which that's what I was referencing this morning for like the warm-up. But in terms of what you're looking for, there does have to be a metal present and it's going to be bonded to one of the following. If you have no metals and only nonmetals, you're definitely covalent. And so with some of these things we just went over, but I feel like a good list would be helpful for some classes. So this is a good list. Now, as we go throughout today, I might reference back to say, add to your ionic list or add to your covalent list, something that would be important to classify for our study purposes. Okay, where have you guys seen chemical formulas maybe before? Out in the real world. Where have you seen chemical formulas written out before out in the real world? Maybe water bottles? What does it say?
Oh wait, just kidding.
I think it just says water because the general population may not know what H2O is. Yeah. Say again? Yeah. Okay, so like full chemical labels. What else? Oh yeah, out in the real world chemistry lab.
Yeah, chemistry class.
What else? Say again? Paintball on the CO2 canisters, compressed air, right? They probably say compressed carbon dioxide technically. Yeah.
Those little like warning signs that it's like a diamond, it's got the red, like the blue, the yellow.
Yeah. And you can see the chemical safety issues that are there. They may not have the chemical names though. Any more?
No, they have
On bags of
They do on the bags of fertilizer. Okay, that's got all kinds of phosphates and nitrates in it. What about this? Who's ever like picked up at the back of like a cake mix, so you're making something?
Yeah.
Or the nutrition labels on behind the or underneath the nutritional values, it should have a list of ingredients. So there's one up here that says sodium aluminum phosphate. Sorry, I saw another one too. Something with alkali, okay, which means base. Monocalcium phosphate, sodium bicarbonate. Those are ones we're going to learn. Look down here. Okay, we've got thiamine mononitrate, which is going to be vitamin D. There's all kinds of stuff. Calcium carbonate, we're going to learn that one. There's all kinds of stuff that you eat on the daily that actually has a chemical formula that we're going to learn. Okay, so you'll see some of this out in the real world if you actually look for it. All right, so here's your brief set of how do I write a formula, and then we're going to write formulas. And then we're going to say, try to name a formula, and then we're going to name formulas. So these are like your little nuggets of instruction. We're going to go do. So we didn't get to this piece yesterday in class, but we did mention the charges. So we know how to do charges. We just have to figure out how to combine them now. So your first step, step one, you find a symbol of the name that's written for you. You find its charge. Step two, you take both of the charges and you crisscross them. So I'm going to demonstrate that up here as you guys are finishing up this part. So if you're getting a symbol, and I'm going to utilize this one down here, you found sodium, and if it's just a simple binary compound, that means it's two elements and that's it, that's all that's involved. For example, sodium and chlorine, I go and find their symbols, Na and Cl, sodium and chlorine. Everybody finds sodium on the periodic table. Point to it, thank you, point to it. What group is it in? One. What is its charge? If it were to form an ion? Positive 1, right? Look at chlorine, find chlorine, it's in the halogen group. What is its charge when it forms an ion? Negative 1, okay? So we've done that, and I'm doing a simple binary one first. If it weren't a simple binary one, you'd have something like a polyatomic ion involved. You need to look at your sheet for now. If you don't, you're eventually not going to have that sheet, so begin memorizing, making flashcards, whatever works for you. Okay, so as we go now, we're going to just take our two charges. We're not going to take the sign. Okay, so no sign, no pluses and negatives. But we're going to just crisscross, and here's how you crisscross. This one comes down here below the Cl. This one comes here below the Na. So that's called crisscrossing. Crisscrossing charges. So essentially I have Na with a 1 from this chlorine up here, Cl 1, and where did this 1 come from? From the sodium. Okay, so I'm going to color code these. The first one, the 1 came down here to the chlorine's subscript, and the chlorine's charge came down here to form the sodium subscript. So we just crisscross the charges, no signs, just the numbers, and we're taking the numbers. Now, many times I told you what do we normally do with the 1s when they're written here? We just leave them out. We just don't write them, so we write it as NaCl. But you're assuming that the omission of a number means that it's actually a what? A 1. So that's what we're doing. We're crisscrossing charges. And I started with a very simple one because we all know sodium chloride. I want you guys to now look at this example. We have calcium. Look at calcium on the periodic table. What group is it in? Second group. Okay, so calcium gets a 2+ charge, as I have written here. Chlorine's in which group? 7, so it gets a -1 charge. We're going to take the 2 and take the 1. We're going to crisscross them. And that leaves us with calcium with a little 1 next to it, and chlorine with a 2 next to it. And that's the formula of calcium chloride. It's really not bad. That's it for binary, okay? So we're going to go through a couple of these together. Actually, let me show you one more slide and then we're going to do this together. Thumbs up when I go on. Symbols, charges, crisscross. Symbols, charges, crisscross. All right, so polyatomic ions are a little different. Write down your instructions or read it here. Okay? Write down what's on the board, people. You're going to thank yourself later. So if we have a polyatomic, we want to put parentheses. Polyatomic parentheses is kind of how I'm going to keep referring to that. On our overall ion, before we crisscross charges, and that will always, always, always get you the correct answer. So the idea is that as you are looking at my example up here, look at magnesium. Which group is it in? Magnesium? It's in group 2. So overall lost 2 valence electrons, has a 2+ charge. Acetate is one of the polyatomic ions that's on your sheet. And you can definitely tell it's a polyatomic ion, because what does poly mean? Many. And then atomic just refers to gram. Refers to what? It didn't refer to gram, it referred to atoms. And then it's an ion because it has a charge. So there's many atoms in this ion, which we're now going to call a polyatomic ion. Okay, so the idea is that you're going to put a parentheses around acetate. So here's how you put it. You put it around the C and the O2. Leave the 1 charge on the outside. And then we're going to crisscross charges. This 2 goes out here to the outside of acetate. And this 1 comes to the inside of magnesium. So what's my overall formula now that I've crisscrossed the numbers? Mg. Okay. I'm going to put a 1 there just for now for placeholding. And then what? Whoa, what's in front of the C? Parentheses. C2H3O2, parentheses, 2. So this is the correct answer. This is magnesium acetate. What many people like to do, just because they're figuring out how to put parentheses on things, they just do Mg, C2H3O2, 2, because they crisscross the charge, right? But what does that look like? 22. That means I have 22 oxygens, which is just a big fat lie, right? How many options do I have? I have 2 in the acetate, but I have 2 acetates total, so technically how many oxygens do I have? 4, because there's 2 times 2 there. That is wrong. This is not right, because it looks like you have 22 oxygens. That's why we have to put the parentheses on it. Cool? All right, so everybody just got a card, right? We're just going to do this for a bit of time. I want you guys to partner with an appropriate ion and write down the formula of your compound. Partner with an appropriate ion. Okay, when I say go, just wait a second. Partner with an appropriate ion and write down your chemical formula. We will name them shortly, okay? After you partner with them, let's say I partner with Cam. Cam and I are going to switch cards because I can't have the same card when I get done, okay? Go. Write down your formula. Write down your formula.
Oh, yes. Non-metal. I need a non-metal.
Yeah, but you have
This liquid is so... I know. Wait, so this is all metal, right?
Write the formula down. Write the formula down.
Wow.
3, 2, 1, freeze. Freeze. Okay, freeze. So you have paired a cation ion with an anion. You are crisscrossing charges and writing the formula down. You are going to switch that card with the person you bonded with, and you're going to rebond, rebond, rebond.
Oh, yeah, rebond.
Yeah.
Well, I need a plus.
Yeah. Yeah.
For the answer, you don't have to put the charge.
On the answer, you don't put the charges. Use them to help you, and that's it. Yeah. That's a negative one. All right, you're going to find your seat in 10, 9, 8, 7, 6, 5, 4. I need another medal. 2, 3, 6, 2, 1. Okay. All right, so as you were moving around, who had to bond together? Okay, so potentially metals and non-metals, but some people had polyatomic ions, right? So in general, we bonded what to what? Cations to anions, right? Normally ionic is just metal and non-metal, but unless we have a complex one like a polyatomic ion. So I've listed a couple of the combinations you guys were making up here, okay? So write down these with me, and I'm going to look at some of the ones you guys had as well. First one up here, write this down with me. Not optional, this is going to be our basis of our notes that we're springing off from. Write this down. Cation column and an anion column. We're going one by one, okay? All right, so our sodium had a 1+ charge. Raise your hand if you had a sodium involved in one of your compounds. A couple of us. Okay, so sodium got around there. And then I'm gonna name this in a second for you, but we're just writing formulas first. We'll talk about naming in like 5 minutes. So I have sodium and I have CO3 2-. Notice on this polyatomic, what have I already done for you? I've already put parentheses because you need to be sure that you're doing that just to keep yourself safe there, okay? Because polyatomic is a big happy family, and you don't need to be a homewrecker and break it up. You need to stay together, okay? So sodium crisscrosses its charge over, and carbonate, CO3 2- crisscrosses its charge over, and what do you get? Na. One. Okay. Now, if you end up dropping the ones because you're just like, hey, it's not worth my time, it's fine. You don't have to write the one. You could have written it as Na2CO3. Boom. So we're just crisscrossing charges. Okay. So both of these are correct, either way you write it. Next one. Do the same. Crisscross charge, and I want to know the formula. Actually, take a second. Let's go through 3 or 4 on our paper, and then we'll talk. Write down the symbols. Crisscross charge, write the formula. Oh, gosh. Alright, tell me guys how you cross the first one. What's the formula? Li, right? And you put 1 and 1 there to be your numbers, that's fine, or you could write it as just Li, I. Okay, next one. Parentheses. So what? So 4, parentheses, 3. Okay, so you're crisscrossing charges, polyatomic ion, parentheses. Next one. So you're putting the charges, crisscrossing the charges. Great. Next one. K2O. And remember you're writing your subscripts just a little lower than the bottom of the letters. Next one. K1. Parentheses 1. Okay. Or I could just write this as KMNO4. If you keep your parentheses there, it helps you see the second name. I think parentheses help a lot in the very beginning of our learning together. Next one. Oh, I didn't put the parentheses on this polyatomic here. There we go. Okay. Parentheses NH4. 1. Whew. Okay. So let's look back at our list here. A lot of letters, right? We're going to start to, instead of saying K, Z, O, E, we're going to stop spelling them, and we're going to actually start saying them by their appropriate names. Okay, because I don't want to be spelling names the whole time. So, I'm going to scroll back to the top, and we'll come right back down here. I want you guys to tell me if this compound is a binary ionic or a ternary ionic. So, the very first one. Binary ionic or ternary ionic? Ternary because it has a polyatomic ion in it. There's Na, there's C, and there's O. There's 3 elements involved. Tell me, ionic, binary or ternary? Binary. Okay, I'm not going to highlight that one. Next one. Ternary. Okay, next one. Binary. Next one. Binary. Next one. Ternary because it has K, M, N, O. Next one. Ternary. All right, so I have highlighted the ternary, so I'm going to go back and let's talk about the binaries. If you were to just name the binaries, you're going to name them like you would have just with an "-ide" ending. So name this one for me. Lithium, and I would write these names down as we go. Okay, lithium iodide. Good. Lithium iodide. So we took iodine, and what do we do? So we dropped the ion and added the ide. Okay, you have to be very, very, enunciate what you're saying, right? Next one, that's binary, name it. Beryllium, is it phosphate? Phosphide. Okay, so beryllium phosphide. Beryllium 2 L's? I'm going to put 2 L's up. Okay. Spelling. I think it's 1, 2. I just kind of second guess myself. All right, but phosphide and iodide are the pieces we're looking for. Next one. Potassium what? Loud and proud. Oxide. Good. So everything, just like you have a first name, last name, compounds have a first name, last name. You have to look at their first element and their second element to get it, though. Now, whip out that polyatomic ion list. The little teeny tiny polyatomic ion list. We're about to hit this up. You want to be looking at this when we go. Who does not have one? Oh. Alright, can I have this back to the phone? Sorry. Okay, so as we go, you're going to be looking for first name, last name. Now the first name, sorry, this is all screwed here. The first name is what the element symbol is. The second name is the polyatomic ion that's listed here, okay? So, first name, sodium. Second name, look for something that says CO3. No, name it as it says. It's one name. Do not put like carbon and oxygen and hydrogen. Don't try to name it like you see the letters. Name the name. Carbonate. Good. Next one. Aluminum. And then SO4 collectively is sulfate. Now pause for a second. Carbonate, CO3, but on the name chart here it says CO3 what? 2 minus, right? CO3 2 minus. So that's where that CO3 2 minus came from. Like that's its charge. But when we combine it in a neutral compound, there's no longer a charged particle there. Sulfate, same thing. SO4, 2 minus, right? But as I crisscross the charge away, it still is called sulfate. It's just you don't see the charge anymore. Next one. You're doing this one, right? Potassium permanganate. Good. Potassium permanganate. Next one. Now, before I move on to this one, actually, notice that this one is a weird front symbol. This is actually on your polyatomic ion list. What is it? Ammonium. And then that's the NH4. And what's the ClO3 one? Chlorate. Ammonium chlorate. So everything has a first name, last name. First name, last name. Yes.
How would you know to put NH4 first?
Okay, so good question. And this is something that you might want to note on yours as well. You always put the cation first, the anion second. Always. Cation first, anion second. So the one with the plus sign first and with the negative sign second. Okay? So terminology is going to be key here. So now we're going to go to this part here. Look on your sheet. We're going to go here. I have not told you how to use transition metals yet, but I'm going to show you kind of as we go. So specifically, work with the ones I'm telling you to work with first. So we have to write the formula out now, guys. So have your polyatomic ion list in front of you. Everybody find calcium on the periodic table? Everybody find calcium? Tell me its charge. Okay, so I'm going to start by writing the charges out. So here's the key point. 1 second. If you don't have an "-ide" ending, listen. If you do not have an "-ide" ending, it is probably a polyatomic ion. I don't know if you noticed, but what were the ions ending with here? I'm sorry, on the polyatomic ion list. 8 and 8, most of them, right? So this ends in 8, so this is going to be a polyatomic. So look at your polys and who's oxalate? Is oxalate on yours? C2O4 2 minus. Okay, so I'm teaching you pieces of this as we do examples. What do I do with charges? Crisscross them, okay? So as I crisscross them, I end up with Ca2 parentheses C2O4 parentheses 2. Okay, so what's the ratio between calcium and oxalate?
1 to 1.
Say again?
1 to 1.
It's 1 to 1. It is really 1 to 1, but it's written here as 2 to 2. But if I have a 2 to 2 ratio, I should simplify this, and this is how you have to do it with Ionic. You have to simplify the 2's down to what? 1. So truly the formula is what? Ca parentheses C2O4. I need somebody other than Anthony with me today. I need to, even if you're unsure, try, right? So I'm taking these 2's and I'm reducing them down to 1's to call it calcium oxalate, CaC2O4. Okay, let's go down to 6 for a second. 6. Everybody find lithium. What's its charge? Positive 1. Carbide. Who does that sound like? Carbon, right? So that's an "-ide" ending. If it is an "-ide" ending, it is like 99% of the time straight off the periodic table. Because "-ide," rather don't have to memorize polyatomic ions, "-ide" rather use PTOE. "-ides" are from the PTOE. Got it? So, carbon is from the periodic table. What is its charge? So no one said +4, right?
No.
Okay, I know it could be plus or minus, but we're not going to say plus because we already have a positive charge here. Two positive charges don't get together. So it's 4 minus, correct? Crisscross, what do you get? C. 1, right? I'm just going to put C. Lithium carbide, right there. Okay? Do 8. Tell me what you're writing down. Oh, Al plus 3 minus 1. Is that what you said? So fluorine, and this is a quick reminder. Look over here if you're looking at fluorine on the wall with me. Fluorine is in the halogen group. Fluorine has how many valence electrons? 7. It's going to gain 1 or lose 7. Gain 1, leaving it with a charge of -1. Crisscross, you got AlF3. Aluminum fluoride. Now the ones from the periodic table are quite easy. Let's go back to one that's not from the periodic table, meaning it's from a polyatomic ion list. We'll do aluminum permanganate, okay? Aluminum's charge, +3, permanganate. Say again? It does. It's a really pretty purple color, but good charges.
And more.
At negative what? -1. It's just a negative, it's a -1. Okay, so crisscross those, what's the formula? Al. MnO4. 3. Because if you don't put the parentheses, it looks like I have how many oxygens? 43, which is bogus, right? Not right. Okay, let's do magnesium cyanide. Now, I told you there were a couple, like 99% of the time, ides mean what? Right up your table. Now, you look up there and you'll be hunting for days. You'll never find cyanide. Okay, so that's telling you it's where? What's on the polyatomic ion list, and you're looking there now. Before you get there, what's magnesium's charge? Because it's in group 2, and then cyanide, CN, 1 minus, crisscross, what do you get? Parentheses. Because you have to, this is a polyatomic ion still, so 2 comes through the outside of the parentheses. MgCN2. Okay, so rules of thumb. If you see I, check out the periodic table. Crisscross, done. If you see 8 or 8, you're looking where? Polyatomic ion list, still the same thing. Parentheses though, crisscross charges. Now, I don't know if you noticed, but you see this weird middle initial right here? Okay, so this is basically a transition metal. Look at cobalt. You see cobalt in the middle of the periodic table?
Yeah.
Okay, it's not in a group, is it? It's not in a standard charge group. So how the heck do you know it's charged? I have to tell it to you, right? I have to specifically say, this is cobalt's charge. And it's a 2. So let me go back to that slide where I skipped, just to show you the information up front, and we're going to go name those as well. So here you go. Transition metals, right? Transition metals don't have a standard charge. All of those ones you're working from already, they have a standard charge. So the transition metals which don't have a standard charge, we have to actually indicate that in the formula as a Roman numeral. It's called the stock system. Who read about that in reading guide 9? Okay, you read it. Now you know what it is. Okay, it's called the stock system because in the stock room, by stock chemicals, this is how it's denoted. So the Roman numeral will tell you the charge of the transition metal. And it's always right after the name of that transition metal. So it's no question. It's going to be that's the charge of that metal. And I've listed some common ones on the top up here. Now, I can give you anything because as soon as you see that Roman numeral, you're like, oh, well, it's a charge. The zirconium, niobium, cadmium, mercury, I can give you any of the transition metals. As long as I give you the Roman numeral, you should do it. So the common ones we'll use are up here, but I'll show you those in a second as well. So looking at this example, 10, everybody find 10 on the periodic table. And 10, and now you're like, what's the symbol for 10, right?
That's a
10.
10. Oh, I know it's
Okay, everybody find 10. It's gonna, what's the atomic number? Atomic number like 80,
Oh, it's 50.
50.
Oh, it's right here.
Okay.
I was looking for my
That's it.
because I couldn't find
Okay, everyone, what's the charge of 10?
2.
How do you know?
Because it says it.
This Roman numeral is like, hey man, that's my charge. Okay, so there's a 2 charge here. Everybody find chlorine.
Wait, how do you know it's positive?
Oh, sorry, fun fact. Here's a good question. How do you know it's a positive 2? 1, it's in the front. 2, it's a metal. Metals always form positive charges. And, okay, that's it. So I got 2. And how do I know it's a transition metal? It's actually called a post-transition metal because the transition metals end at D block. But it's a post-transition because it's actually after. Say again?
So why is it over there?
Because generally it's it can just serve as a metalloid, serve as a semiconductor. They have different properties, but they're still post-transition metal. We're learning the periodic table. It's a really intricate person. We have to really get close to it and then earn its trust, and then we'll learn more about it. Okay. So chloride, come on, chloride. Cl. Charge. If one has a charge, the other one has a charge. So it's in halogen group, 7, 1 electron, crisscross, Sn, Cl, 2. This is 10,2 chloride. That's how you have to say it. You can't say 10 chloride because I'll say 10 what? And you have to say 10,2 chloride because you have to tell me the charge as well. Do the next one by yourselves or with the person next to you.
Lead. Let's go find lead. There's lead that would, I don't know why I was not. It is, oh my gosh. It's 4 in the Oh, I didn't. So that is what
Alright, formula. Actually, before you say formula, process. 3, 2, 1, back to me. Zane, what's lead's charge?
Positive 4.
Okay, lead's charge is positive 4. Mackenzie. Shh. Mackenzie, what's sulfide's charge? Negative 2, right? When you guys first crisscross, what did you get? EB, 2, S, 4. Okay, that's what you got when you first crisscrossed. But what do you have to do for ionics? So, EB, S2. This name, I know it doesn't look like it, but this name is lead 4 sulfide. It's still lead 4 sulfide. I just reduced it. So sometimes when we're going from from formula back to name, we have to really slow down our thinking. But if we're just going from crisscross charges, oh, I got to reduce that. And then go back to look at the name I told you, you can name that as lead 4 sulfide. Okay? Did that kind of sink in just a little bit?
yeah.
Some of us, okay. I have some examples to do with you, okay? Oh, before I do that, examples. I just said, in general, this is a big generalization that transition metals have variable charges, except for like 3 of them. 3 of them have standard charges. Okay, here they are. The 3 standard charges are zinc, always has a 2+ charge. Write this down. Zinc always has a 2+ charge, and I remember that because the Z kind of looks like a 2.
Yeah.
Okay, the Z kind of looks like a 2. And my favorite metal, okay, kind of. I have a couple of favorites, but my genuinely favorite metal is silver. And it's silver 1.
Why?
Because it's this charge, and that's the only way you'll remember it if I do it like that. My AP students still go, oh yeah, silver's number 1. I'm like, you guys, crack me up. Okay, silver always has a 1 charge. Always, 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 always. And then cadmium, CD, always has a 2 charge. And I remember that because look where zinc and cadmium are. They're right next to each other. They're in the same area. So those 2 right there always get a 2+ charge.
So if you remember zinc.
And silver always gets a 1+ charge because it's right before cadmium. Okay? Good? So if I ever say something like, I'll give you an example. Ready? If I ever say something like zinc. Let's do zinc iodide. Zinc iodide. Notice what did I not put in the middle? A charge, because do I have to? Because you know it, right? You know it's what? 2 plus. So if I say zinc iodide, what's the charge of zinc?
2.
What's the charge of iodide? -1. What's the formula? I2. So that's zinc iodide. If I say silver chloride, what's the formula? What's the charge? -1. Okay. And Cl, -1, crisscross, what do you get? AgCl. Just do not write Roman numerals for silver, zinc, or cadmium. The other ones you have to write Roman numerals for. All right, we're doing the examples I so promised you. Here we go. Back here. Cobalt 2 hydroxide. So cobalt has a what charge? This is number 5. Number 5. So cobalt has a. I'm just trying to get my pretty pen. Sorry. Okay. So cobalt has a 2 plus charge because the Roman numeral said so. Now normally you see ide. What do you normally think when you see ide? Periodic table. Then you look and you're looking for hydroxide and you're looking and you're looking and you're looking and you can't find it. So it's not, right? So what does it have to be? Okay, so I know you're going to go, oh, let's write ho. No. We're going to write O because it's hydroxide. Do not do it. Respect hydroxide and move on. And write OH -1. Crisscross charges, what do you get? CO. Hold on. Whoa, we missed something. Parentheses. O. And then 2. That's cobalt 2 hydroxide. Okay, let's do another one. Number 9. Number 9. Do that with the person next to you. With the chromium. Do all the Roman numeral ones there. Do all the Roman numerals.
Oh, I see. Okay.
No, lead is not always 2. Check yourself. Check yourself. Okay.
Yeah. I got people. So it's minus phosphate.
Okay, come back to me. 3, 2, 1. Okay, so in terms of looking at charges, are you guys okay on the periodic table? Yes. Okay, so I'm just getting a temperature probe here. In terms of transition metals, how do you get the charge?
The number
Tells you
So Roman numeral, unless it's
cadmium, silver, or zinc.
okay, cadmium, silver, zinc, because those have standards. Silver's number 1. Okay. In terms of the 8 endings and I endings, you're looking to your polyatomic ion list for now. All right, so we're gonna practice some more of this, guys. We're gonna practice some more questions on the transition metals I didn't read right now. Yes.
The transition metals says there's 2 ways of knowing how many electrons will have both.
The other one I'm going to tell you tomorrow. Just wait for it. Can I tell you tomorrow? Okay. I did say 2. All right. So here's your last bit of instructions on how to name, not write formulas, but to verbalize the name. And I think you know this because I think we've been doing it the whole time. But if you want something to write down, here you go. I'm going to spend like a minute here. That's it.
A minute. Starting now.
Wait, a minute? There's no point.
Read it. No, read it. Read it. Read it.
Reading it is like
Write down changes.
writing down. Nothing really.
Talking it out. Honestly. We know how to do this. If you would like, while some folks are writing down your instructions, because some people work differently than others, there is a second set of examples right here next to the one we were working on. You can try to start writing the names of those. I'm going to do this in a second after folks get their bearings. Let's start right here. I'm going to melt it and it'll freeze tonight. All right, so come back to me. We have been naming chemical formulas for years. If I said NaCl, you automatically said sodium chloride. If I said SO2, sulfur and something oxide, right? We're going to get to covalence more tomorrow. The ionic ones take longer to learn, so since I did them first, so that you have longer to learn. So we're going to name them now. And then we're going to be using this sheet right here to follow up with. You look at your polyatomic ion list until you're ready to stop, being weak and looking at it. You'll be weak for the day, but I want you eventually to stop. Eventually it will stop. Okay. Here we go. Everybody, identify first. Is this a polyatomic, yay or nay? First. Yes. The first name is what? Ammonium. The second name? Whoa. Okay, so here's the trick. If it is a simple non-metal straight off the periodic table, you end in "-ide", because I'd rather use periodic table than memorize the standard list, right? But if it's not off the periodic table, meaning it's not a simple non-metal, you have to end in "-ate" or "-ite". So this is ammonium sulfate. Everybody look at the periodic, or look at your polyatomic ion list. Find sulfate. Does sulfate have SO4? Yes, it does. That is sulfate. Okay, so ammonium sulfate. So everything has two names. Do not get crazy and like calcium, phosphorus, just some oxide. No, 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 no. We got two names. That's it. Calcium. Sorry, I did not mean to say that one out loud. Second name?
Phosphate.
Phosphate. Name the rest of them. No, not out loud. Write on paper. Write on paper. No, no, don't get crazy on the names. It's only this guy and that guy. That's a poly. Yeah, yeah. It's a poly. You can't use you can't use prefix. Okay. It's in psychology. Actually, I don't feel oh my god, I am so
What do you mean philosophy? What was the word?
If you're doing carbon, but it's like
carbide.
periodic table.
Carbide.
Carbide. Okay. That's what I would think.
I know it is.
But you know, how do you know to put that
It's the transition metal. Remember the transition metals have root minerals? That's not just it's just even polyatomic catalyst. It's only a couple that have those, and that you'll get it. Okay, but it's not previously. Like I love chlorine, my favorite.
Do you like Playboy Teddy?
Yeah.